everybody, we're back. So right now, we're gonna have Conrad Frank present with Arctic Microgrids with Conrad Frank. He's presenting mobile right now. He's on his phone. So yeah, let me switch over, guys.
Okay. Good evening, I'm Drazzy, with Conrad.
So, components on the microgrid needed to be able to achieve a temperature around negative 40 Celsius Fahrenheit, which is extremely cold. It was really hard to find equipment that essentially would go down to negative 40 Celsius because it's so cold, and we had to work really hard to find components that would meet these temperatures, some of which were custom solutions.
I could go on about the power generation as well too. We worked countless hours on that, but I'm more interested in talking to you guys about the cybersecurity aspect of it, because there can be a lot of vulnerabilities that come with something like this, and there are a lot of adversaries that want to hit something like this because of how important it can be to our government and to like research in general. So we're gonna move on to the next slide. So this is kind of what I crossed some things out and I went through and looked at some things, but this was originally what our network was supposed to look like, and this is kind of how it changed. So we were not allowed to have an outside signal during the project. About halfway through, we found out that we weren't supposed to be transmitting or receiving anything, because they want it so blacklisted. They wanted it to be completely unreachable, and that the only thing that was supposed to be known was the location of where this microgrid was, and this was for the government, of course. They didn't want, so of course we took out the firewall and all that other stuff. So we've got two things on this network. We've got power and communication, and then of course our generators. So the red things are our generators, green is power, communication is all blue. So we just had controllers and servers and a couple of just stations that were monitoring everything. It wasn't really a complicated system. Just everything had to be blacklisted IPs and stuff for security purposes, of course. So let's move on to the next one. So we had all of our electrical equipment. We studied and went through a bunch of testing phases and like other things with this microgrid before we actually got the communications part of it, because we needed the power generation first. So after all the engineers went through and found sufficient DIRs and controllers and feeders, things like that, or whatever we needed for our electrical equipment, we had to connect all of them. So we had the main server, of course, for data communication. I had to implement special aircraft grade Ethernet and connectors that were rated down to negative 60. That was kind of just our standard. We went with negative 60. It's extremely hard and it's very, very, very expensive to go to negative 60. And we had to also heat our server, which cost us a lot of energy in order to go down to those temperatures. Now, the nice thing was you can keep equipment in some sort of storage container and keep it heated with your personnel. But again, it's extremely small and it's going to be costly of room to keep things inside of that shipping container. So due to the power generation as well, we had to think about like our data transfer, especially like our 3-phase and 1-phase and all the different types of electricity that we had running through the grid, because it is extremely complicated for a CS guy to jump onto a grid and be like, okay, we have to think about all this different electricity stuff. And the Aurora Borealis also has an extremely high effect on data transmission. It can actually wipe out electronics in the Arctic Circle. It doesn't happen very often, but it has happened. So we had to think about things like that as well. So what we wound up doing was mounting steel brackets around our Ethernet cables to shield them from our power generation sources. And then the entire thing was enclosed in a box, which somewhat helped us from the Aurora Borealis, but that was probably one of our biggest challenges, because if it was strong enough, our controllers outside would be pretty SOL, which was unfortunate because if something bad were to happen and people could possibly die. Other security components that we had, or security in general. So we had to silence the system from all transmission. We had to collect all of our EMF because we didn't want anyone outside to be able to get to it. I think it was a 15-meter parameter. We didn't want any of our transmission to be able to be collected. We painted everything white. So some components needed special paint, such as our wind turbine. It needed a special like carbon I don't know what it was. I'm not the person who created the wind turbine, but it needed a special paint to go down to the temperature that it was rated to be efficient, to be able to generate power. And it was kind of an issue, but we just wound up going with black because it's what the chemical composition of the paint that needed to be on that was. And we couldn't wind up following through with securing that. We also had solar panels that were black. We had to leave them black because you can't paint a solar panel and expect it to be effective. So the microgrid also had to be quiet because it was planned on sitting on ice, and typically Russian submarines can actually pick up sounds and things from the microgrid, and we really did not want that to happen because one of the biggest security risks is actually where that is located. So if the microgrid was exposed to, or if there was a way for a Russian sub to track where our microgrid was, essentially our mission would be compromised because they could see it from GPS and continue to track it for long periods of time. So we also had to use like Faraday cage for all of our EMF and just kind of like wrap it in chicken wire and stuff. It's kind of just a bootleg thing that we did. And we also had to implement all kinds of locks that were capable of going down to -60, and we had to implement just all kinds of cybersecurity equipment that was able to go down to those temperatures and was more secure than what would be on a normal system. So this is kind of my summary slide. So people will die essentially if our cybersecurity equipment or our security in general is not good on a Arctic microgrid. The solution, of course, is meeting the specifications for security on an Arctic microgrid, whatever that is. Again, this is a developmental thing as well. The government has not found or implemented any documents that really match cybersecurity for this. They've matched a lot of the engineering and technicality sides of it, but these actual cybersecurity aspects of it have not really been written. Again, normal equipment just cannot run up there, and modifications that we made were, of course, aircraft gate Ethernet, transmissions were all encrypted, waitlisting machines, controllers that had no parts. That was a big one, and it's extremely difficult to find controllers with no moving parts because most of them have like mechanical switches or something else that makes them unsuitable for going to -60 degrees. And then we also had to have redundancy, so if a system went down, we could easily and quickly replace it. So that means a lot of our systems also had to be small because we needed more than one of them in case one of them broke or one of them went down and we just didn't have time to fix it, or the soldiers on the project didn't have time to fix it. So what I did on the project was I certified that all of like theoretical cybersecurity elements were in place for data transmission, as well as the harsh environment rating for the cold. And then we also had a safe communication layer, and we couldn't be tracked. Do we have any questions from anybody?
We had one question from Yoda Dog, and that was,
Okay.
was there enough wind to have the turbine work better than solar? And did this grid have a large battery backup?
Okay, yeah. So I can talk about the DERs too quite a bit. So we had, let me show that document again with the so there are 6 DERs on this diagram. You can see them in the red, kind of at the bottom. All of our DER generators we had a wind turbine, we had solar, we had hydro, we had a battery pack, and we had a regular generator, and we had I think the turbine, we actually used like a turbine. I'm not entirely sure. So our battery pack was one of the biggest issues. We only could get a battery pack that was rated down to -20, which was like a huge concern for the microgrid, because if everything froze, our batteries would be gone and we'd have no way of storing our power. What we did was we just wound up throwing them inside of the actual shipping container and just hoping that things wouldn't like freeze. There was talk. Now, I don't know if this got implemented because I'm not in the project anymore, but there was talk about some company that actually wound up getting batteries down to -40, and that they did change the microgrid to something that was along the lines of like a battery that heats itself or uses some kind of like chemical reaction to heat itself. And they just replace the chemicals, or they just have heaters that are low power or something. But again, I don't know if that actually happened or changed. We had some really beefy batteries too. They took up like, I want to say they were like close to 8x8. They were huge batteries and they were extremely expensive.
But the next one is
Okay.
what are these microgrids supposed to do? What is their value / what do they do?
So these microgrids essentially are like allowing the government to be able to research the possibility of not only moving equipment like power stations to the Arctic to be able to generate power and keep things cooler. Like if there's feasibility of being able to generate power in the Arctic, because in the US right now, like people are concerned about having wind farms and solar farms in their backyards and stuff. So it was just kind of a frontier that we might explore. And also the ability to move people, like for example, like a FOB around a forward operating base around in the actual Arctic, using it as like a remote command center. But again, we couldn't use it as a remote command center either because we didn't transmit or receive data.
All right, thank you. So we got another question from InfoSec Axiom. What kind of budget did you use for building this out or implementing?
We did not have a budget. We got a blank check from the US government that said have fun. Now, I think we spent like, I want to say over $1 million on this project. There are things on this project that also, just a disclaimer, there are things on this project that I don't even know, and that, yeah, we're just not allowed to talk about.
Can you say how many kVA this system is?
Kilovolt amps, I actually don't know off the top of my head. That was not, again, I just plugged the shit in and made it work and made it so people can get to it. I really do not know what the kVA of the system was or how much power this produced at a certain amount of time. I just knew that we were running Siemens controllers from some of our stuff. We were also using, I think, some Emerson or some other controllers. Let me think. I think it was all Siemens stuff because it was just easy to use and their software is pretty easy.
Do you have any vendors develop custom solutions for your team?
Yes. Oh, yes. So I think we went with, there were actually a few small startups that do the controller stuff, and we wanted to go with them, and they were actually about to get us some customized equipment. I think Siemens actually wound up coming through with some really customized equipment that was ridiculously expensive because their stuff's all mainstream and it's like buying a MacBook that's better than a MacBook. So yeah, there were custom solutions that were built for this. You need custom solutions for this project. If you're planning on bringing electronics down to negative 40 degrees, you are going to need a lot of custom solutions.
We have another question from Husky Hacks. Do you have a sweet thermal parka?
I do not have a sweet thermal parka. I do. Wait, yes, I do have yes, I do have a parka. Yes, I do have one.
Do you or do
have
you not?
I do.
Okay,
It's
may I remind you, you were under oath.
It's in a locker. It's in a locker somewhere. Yes, I do.
Okay. Real question from InfoSec Axiom. What kind of gear did you wear for that temperature, weather, any public brand names?
Yes. So a lot of it was like Goose Down, I think it's called. I don't remember the name of the stuff, but a lot of it was like down gear. I do remember that. Yeah, a lot of the equipment's actually extremely hard to move in. It's not like readily mobile stuff, and working with the electronics and a lot of the other equipment is like ridiculous. Moving things around, doing normal things that like everyone appreciates is pretty ridiculous. It's good that I was in the military before I did this project, because if I wasn't, I would be like, I probably wouldn't have been able to do a lot of the things that I had to do up there. Helping move stuff around for like the engineers and things was difficult.
Okay. Helen the Tour wants to know, did you see penguins?
I did.
Yes.
You did. All right.
Guys, we're gonna wrap up here.
All right. Well, thank you so much.
Yeah,
Seagrazi.
thank you, Conrad.
Yeah, no problem, guys.